Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. We're a meetup group designed to help people get into Python and machine learning. We'll take people of any standard, even complete absolute beginners. Especially on the first week of every month, we really try to cater for those absolute beginners who haven't even got Python installed on their computer. We do it through a mix of online and in-person sessions, and our next in-person session will be on the 10th of July, on Wednesday the 10th of July, and it'll be at the premises of Amazon Web Services in Brisbane. So if you RSVP to that one, make sure you click on, there's a link in the text on Meetup that'll take us to our registration page, because we need a little bit more information than Meetup gives us, just your name and email address, so that we can give it to Amazon, and Amazon will be printing up name tags for everyone when they arrive. And it's a wonderful venue that they've got there, so it's all worthwhile, and it'll actually be quicker than what we had to do at Brisbane Business Hub, which was everyone had to re-register every time they arrived there to say they were on the premises. Okay, so moving on, tonight we're going to be looking at using a Postgresql database with Python. So we've done other databases in the past. We've done SQLite 3, which comes with Python, and we've done MongoDB, and now we're going to be having a look at Postgresql. And we're going to do it using Google Colab, so you don't even need Python installed on your computer. And I've given you a link here to the notebook. So this link will be below the video that you're currently watching on YouTube. So you can click on that, or if I'm on the Meetup page, and so I'm going to click on the link there, and that's that Colab link. Alright, so this is going to open up in Colab, but it's going to be opening up my copy of the notebook. So you'll see here it'll say changes will not be saved, and that's because I'm logged in here as a different user to the user that created the notebook. So the first thing I recommend you do is click on copy to drive, and that will create a copy. It will rename the title so it's clear that you're in the copy, and you see here it'll say copy of Meetup 204. I've got here there are private outputs, but that doesn't matter because all the outputs will be recalculated as you progress through the notebook. Now this is a live session, and the advantage of live sessions is that you can ask questions along the way. So I'll be listening here on the YouTube chat, and probably a little bit more reliable is the Slack chat. So we've got a Slack channel, Beginners Python, in the Learning to Code channel. On that Slack channel is where you can ask questions about tonight's session as we're going along, and I'll try to answer them, and if I don't see them, hopefully someone else will see it as well and be able to answer them. You can also tell me if things are going wrong, like you can't hear the volume, or the type is too small for you to see. Okay, so getting back to a Colab notebook, these notebooks, I'll just give a quick run through. They're just made up of text and code cells. This is a text cell, it's just formatted text, it's got hyperlinks and headings and stuff like that. And in between each of the cells you can add another code cell or another text cell. This is another code cell, and then we've got some Python code cells. Alright, now the first thing we need to do is just connect. So we'll click on this connect up here. If you don't do that, it'll do it automatically for you later, but take a bit of time. And that's Google setting up a virtual private server for you, so that you can just do anything that you like, and we'll even be installing PostgreSQL databases on that server tonight. So you can see here they're giving us some RAM, 13 gigs of RAM, 107 gigabytes of disk space, and so let's move on. So I've given you, here's the links to Colab, the YouTube of course that you're on, the Meetup event, which is not much more information there, but also our GitHub site. And so the GitHub site, you can look at all our past sessions, and they'll all have YouTube links and Colab links if applicable, so you can find a topic that interests you and go for it there. Okay, we're going to be using Postgresql. Postgresql needs a driver to a connector to connect from Python to Postgresql. So we're going to be using PsychoPG, and we're also going to be using some data from the Brisbane City Council Open Data Project, which will just give us some data to play around with. I'm not really going to go into much detail on how we get data from that. We've done that in other sessions. Okay, and these links are actually going to be wrong because the Brisbane City Council has just changed their links, but they've got static metadata. We're going to be looking at rainfall and stream heights, and so there's some metadata and there's some measurement data. So let's move on down here where they've got the right links. Okay, so we're in a code cell here, and we're going to be using these are both standard libraries. Actually, requests. Can't remember requests is one of the standard libraries, but datetime certainly is. And they come installed on Google Colab, so we can just import them straight away. And we import them just by running the cell, and it's imported them. So now that we've imported them, we can use any functions or classes that are in those libraries. So our first challenge is just to create a list of dicts, so dictionaries, Python dictionaries of metadata and data from the telemetry sensors. These are the old links. I put in some interim data because I only changed it just last week, just before I did this first presentation. But I think I've got it going now with their new links. So these are their new URLs to get the data through their API. So we can just run that, and that will use the request library to go and get the response from that URL, and then we're going to look at the JSON from that response. And I'll just give you a quick look at what it looks like. That's the JSON. So it says total count 286, results. We've had to put a limit of 100 here in the API, because if you don't put a limit of 100 or less, it will just assume it won't let you use the URL. So you can't get all 286 results in once. The most you can get at one time is 100. So anyway, we'll stick with 100. That's probably enough. And then we can look at the results, and in the results there's a list of things, measurements. Okay, so let's look at a few of those records, maybe the first 5 records of that. This is just some quick Python code. I can explain it more, but it's really got nothing to do with Postgresql, so I don't need to spend much time on it. This is just the data that we've got from Brisbane City Council. So we've got a sensor and a value, or another sensor and no value, so that's the dash, and all of these happened at a particular time. So the 11th of June at 7:45 UTC time, so that's 17:45 local time, and so that's yesterday, so it's about 24 hours old. Okay, and we can see here we've got some of the measurements of, this could be either rainfall or stream heights, we don't know at this stage. Okay, that's the measurement data. Now we can have a look at the raw data, the metadata, I mean, that comes, and we've got a sensor, where it's located, location name, whether it's rainfall or a stream height, and whether it's measured in millimeters or meters, and the latitude and longitude. Okay, so that's some good data to work with. They've cleaned up their data quite a lot, although they've now introduced a new discrepancy in the metadata. They're using uppercase letters for their sensor IDs, and in their raw data, their measurement data, they're using lowercase. So we'll just have to correct for that later on. Okay, now PostgreSQL is what you're interested in. This is a database. It's quite a high-powered database. I've been using it for 20 years, and you know, it's the open source database that most closely resembles, in my opinion, Oracle. It's got a lot of features, and it's certainly it's quite powerful, and that probably put people off in the early days. They found it a bit too complicated, and so that MySQL got a bit of a foothold. But PostgreSQL's been going strongly all the time, and I think it's certainly more functionally complete and more industrial strength than MySQL. Now, to use it, we need to use PsychoPG. Now, there's a couple of versions of PsychoPG. There's version 2, which is called PsychoPG 2. I wouldn't use that for any new projects. It's not really much development happening in that one. Most of it's going into version 3, and confusingly, that's just called PsychoPG, which is probably a good thing that they've got rid of the number out of the name. So, and we can just call up by a particular version. But there is no PsychoPG 3. If you want version 3, you just have to use the name PsychoPG. And there's different ways of getting it. You can install it using the square brackets binary, which is what is the quickest and easiest way to install. It doesn't have to do any compilation, and there's no dependencies on libpg. You could also do the C version, which does require compilation when you install it, but it links to the server libraries, and I think this is supposed to be the best performing one. You won't notice the difference in development, but possibly in production environments you would notice it, so it's recommended to use that one for production deployments. And if you have trouble getting either of those working, you just use the pure Python version. It's slower, but it works everywhere. Okay, let's have a look at what Google Colab have given us. Now, this is a code cell, and normally these code cells are for running Python, but you can actually run shell commands on it just by prefixing the command with an exclamation mark. Fortunately, in the shell and in Python, a comment starts with a hash symbol, so that works. And then we just want to cat, which just means same as type out the contents of a particular file called os-release in the etc folder, and it tells us that we're running Ubuntu 22.04. Now with Colab we get a lot of the third-party libraries that come with Anaconda, and possibly a few others as well. So let's see if they give us PsychoPG. So to do that, I'll run the shell command pip list, but rather than see everything, I'll just filter that out through the pipe symbol and grep for just the word psycho in it, and the only thing that we get is PsychoPG 2, which we don't want to use, and that's version 2.9.9. Alright, so we're going to install the PsychoPG with the binary in brackets, and I'll also install Colab Xterm because that'll give us a bit of stuff we can do in the terminal, and then so they're Python installs. This next commands are Ubuntu installs, and we're going to install PostgreSQL and the PostgreSQL client, and then we're going to start that service. So let's run this command, and you can see it's downloading the Python libraries from pippy.org and installing them. That didn't take long. It also installed any dependencies that they may have had. Okay, and now we're down to here. This is the installing the packages into Ubuntu. And that can take a bit of time, but it's getting PostgreSQL version 14 installed. And it's starting the server. Alright, now the server's now started. So, what we want to do is create a database within this server. So we're going to use a That's the create database SQL command, and we're also going to create a user to do that as well. So we'll store the user, the password, and database name in environment variables, and then we can just run this script. And by putting them in environment variables, you don't see them showing up in the process logs with so you're not giving your password away to everyone who reads the process logs. And also by this is going to run on the shell. I mean, we're in Colab, so no one's going to be really looking at it, and it's really a low security database anyway, but we may as well practice these things. By putting a space at the front here on this shell command, it means that command won't even go up in the history, so people can't look at your history and find out what your password was from that. Okay, so by running this, and this is a different way of running it. Remember I said before we put an exclamation mark in front of shell commands, but if you want all the commands to run in the same shell, you need to create a code cell with %% bash at the beginning. Otherwise, if you use several lines with each one with an exclamation mark, it's like you're starting a new shell for each one. And so remembering these environment variables from one to the other won't work. Now the last thing we've done here is created a config file, and that config file is just a convenient place to put a username and password and database name, so that we can use it in our program, and people who can see our source code of our program also can't find out the usernames and password. And it's also really useful when you're deploying your program on some other platform. You can just put a config file there with the connection details to your database, and it doesn't have to match with what was programmed or hard-coded in the program. Okay, so we've created this file. That's a shell command that creates a file called dbconfig.ini with this contents, and you can see that file if you click on the folder over here in Google Colab, and you can see it's created dbconfig.ini for us. I can even double click on that and see it over here on the right. That's exactly what it's created. You can now see the username and password that we've used. So yeah, on a real server you would make sure that you had the permissions restrictive on that file so that other people can't look at it to see what the contents was. Okay. Now, how do you read a config file? That seems to be a reasonably common problem that people have, and there's so many different ways of doing config files. We've done one using the ini format. You can also use JSON, you can use TOML, you can just use a text file. Some people even use Python files for configuration. But this is a way of reading an ini file for you, so you can just import from the config parser library, import config parser, create a parser that reads the file, and then from that create a dictionary. And you'll see by running this bit of code, it creates the dictionary with all the configuration parameters we need to connect to our database. So if you want, I can go through that in a bit more detail, but that's about config files rather than Postgresql. Okay, now let's create some tables in our database. What have we got? So we had a look at the data before, and I can't see it. I'll just remember what it was. We had an ID for the sensor, so that was like the E1843. We had an ID for a location. We had a description of the location. We had the type, whether it was rainfall or stream height, units like millimeters or meters, and then we had some latitude and longitude. So I've just created some field names here. I could call them anything I liked. The data types here you have to choose from the PostgreSQL data types, but most of them actually have a lot of aliases too. So text is pretty similar to, well, it's the same as varchar with a lot of characters. So that means that you can have varying amounts of text in each of these fields. If you have a lot of text in one record and not much text in the other, it will use just a big amount of data for one record and just a small amount of data for the other. So that's why they're called varchars. But in this case, it's text. So in the old databases, there used to be just a char, C-H-A-R, data type, and that was if you put a big number for the size of it, it would use that amount of memory regardless of how much data in it was actually being used. Okay, and we're going to use double precision for our floating point latitudes and longitudes. And if you are going to do anything to do with real numbers or floating point numbers, use double precision. Don't use single precision or real, because they won't play nicely with Python floats. Okay, so we've put all this command. There are SQL commands. SQL commands you separate with semicolons. I've put a couple of drop statements at the top here just in case I'm coming back and running this notebook again. It'll just clean up the data the second time through before it creates a table. And all that is just in a string. So I've put it in a string. You see it's got triple quotes around it, which means I've got new lines inside the string, and I need to pass that through to my database. So the first thing I need to do is connect to the database using my config data, and that's a dictionary, and I just put the double asterisk in front of the dictionary here to explode the data out, just to make it into parameter names for calling this function connect. Then I from the connection I get what's called a cursor, which is a way of looking into the database, and I'll store that in my Python variable CUR, and then CUR I can call on the execute method and just pass in the SQL that I want to execute. So if I run that, it's run the SQL. It hasn't given me any output, so I don't know if it worked, but let's have a look inside the database. So I don't know if you've used Postgresql before, but let's call up Colab Xterm, which is what we installed before. So we'll just load that extension and then run it, and it'll give us a command line terminal into our Colab computer. And so from there I can run PSQL, which is the command line client for Postgresql. Now to run it, the way they've got it set up on Ubuntu is it doesn't use its own set of usernames and passwords for connecting from the command line. It's using the operating system authentication and user model for handling all of that. So the operating system knows who you are, and if you are allowed to connect to PSQL, it'll let you in. Unfortunately, we're root, but root hasn't been set up as one of the users that can connect in through PSQL. But the user that has been set up with all the super user privileges is a user called Postgres, and that happened when we actually installed Postgresql. That user got set up. So we want to do a sudo command as this user Postgres to run PSQL, and then PSQL will see that and go, oh yeah, Postgres is allowed to do anything it likes. So let's just copy that. So I did a Control C, I'm on Windows to do that, and now I'm going to paste it into my terminal, and I think I might have to do Control Shift V. Yeah, so Control Shift V to paste into a Ubuntu terminal, and that's let me in. Okay, so I'm running PSQL 14.12. The username is Postgres, it's telling me, and I can now start typing in some Postgres commands. So I hope you're following along, because this stuff is quite fun to feel like you're managing a complete database system on a remote server. So you could type help if you wanted help, of a list of all the commands, or even \?, I've given you a few that you can do here. So \L will list the databases that are installed. So we can see BPAML 204 is installed, so that we installed that earlier. So that was the database we created from the command line. Well, we want to know if there's any tables inside that. So let's connect to that database. So \C BPAML 204, and I could have connected right from the beginning in my original command. I could have put the database I wanted to connect to, but I didn't put any, so I wasn't connected to any. But now we're connected using the \C command, and now I can use \DT to tell me a list of all the tables that are currently installed in this database. And there's one table there, table sensor, that we created, and it's got the owner BPAML. So this table was created through a Python command when we sent that SQL through, which was what we just previously did. We can have a look at the structure of that table. So /d and table sensor. Okay. And there it is. There's the data structure we created. We can even run SQL commands on it. We can just type the SQL commands directly into the command line interpreter. And remember to put a semicolon at the end whenever you type in your SQL, or if you've got more than one SQL command on a line, then put semicolons between them. Okay, there we go. It shows us that it gives us a heading, but it says there's 0 rows in there. So we're going to have to add some data into the system. So that was fun using Xterm. Now we could do the same thing, which was check if the table is created, doing it from Python by using this bit of SQL. This is pretty specific to Postgresql as a way of finding out which tables and types are in your database. So there's the command that I've run. I put it into, so just as before, we connect using our dictionary of configuration parameters. Then we create a cursor, and with the cursor we execute the SQL. But this is SQL that we've got now is not a doing something, it's actually a query that will return results. So then we can call fetch all on our cursor to get all the results, and it'll put it into our list of rows, and then we can iterate through the rows and print them. There was only one, and you can see how the results came back. So you can see that's come back as a tuple. The parentheses at the end show that it's a tuple and comma separated. And that's the default for PsychoPG. It will return the results as tuples. But sometimes you want the results to come back as in a different way. Like I like dictionaries because it tells me what the field name and the value is for each of the fields that comes back. At the moment I don't know. I have to know what my original query was to know what public is and what table sensor is or what base table is. So when you connect using PsychoPG as well as our connection parameters, you could add extra parameters in, like a thing called a row factory, and there's a row factory called dict row, which I can import in from psychopg.rows. And if I specify that as one of my parameters, then all the results will come back as dictionaries. Similarly, I could use I can specify on each cursor what the row factory is. So on this first cursor it'll just use what the connection was, which is a dictionary row, and then I'll create another cursor, and this time I want the row factory to be a thing called a named tuple row. So let's run that, and you can see our first result is a dictionary, and I think that's pretty useful. It gives us the name of each field and the value of each field. So I've printed the row, and I showed you how you can pull out individual values. I mean, it's just standard dictionary terminology in Python, you just use the square brackets and then the key name inside the square brackets. So to get the table name, you just say row square brackets table name, and that will return that string, table sensor. Now if I use the name tuple row, this is what it looks like. Some people really like them. I've not got used to them, so I don't really know what the benefits of them are, but that's the thing you can do. Referencing individual fields inside the named tuple is uses the attribute notation, so you go row dot table name rather than the index notation row square brackets table name. Some people like that. Alright, so that's all our metadata data structure. Now we want to put some data into that database. So let's have a look at what we've got. So we'll look at the first 5 rows. So that's what they look like, and there's 92 rows total. So Brisbane City Council's cleaned up the data. When we first had this data, they had mixtures of upper and lower case, and they had missing spaces. They had spaces inside the field names, and it was all a bit more difficult to work with. So I had to do all this thing about renaming keys so they don't include spaces, and here's an example of what it used to look like. But now it's looking a lot better, so we don't need to do that. So solution, our challenge was prepare the data for insertion in the database, and solution 2 no longer necessary. So I'll just take my raw data for the metadata and store it in my list of data that's ready to be used. Okay, now I want to insert this data into the database, and SQL has different forms of the insert command, and actually this is SQL is responsible for some of it, and PsychoPG is responsible for some of it as well. So you can do it this way. We just say insert into table sensor values and %s, and this is a way of binding our data in. So you don't ever construct these SQL statements with the data values, and the reason you do that, you don't do that, is because you then become prone to a thing called SQL injection. So so for example, if you said you had an input field to someone, what is your name, and they answered it as semicolon drop database semicolon, and then you said insert into table sensor that value, the semicolon would end the SQL command you did, and then run the next SQL command, which is dropping the database, and so you'd lose the whole database. So anywhere where the user's got control over the data, you would never use that data to construct an SQL statement using string manipulation. So the way you do construct it is is using bindings, and the first way, well, here's 3 different ways of doing the bindings. So you have an SQL statement with some placeholders to say where the bindings are going to come into, and then you provide, say, a list or a tuple of values that have the data in the right order, and they will get inserted into each of these fields, and then these fields in this particular form of the command need to know which order the fields were created in table sensor, and it will put them in there in the right order. And then you don't have to worry about SQL injection. PsychoPG and Postgresql will take care of that. In fact, with PsychoPG 3 and the latest Postgresql, a lot of it is done up on the server, handling the bindings. And that's what I mean by this, uses server-side bindings. Alright, so this depends on the order of the columns in the table that they were created, not what they look like in alphabetical order, but just the order they were created. and the order that we provide them in our tuple. So there's two things that could go wrong there. I don't like this form at all. So we could insert from a dictionary of keys. So we insert into table sensor and then these values, and then I provide a dictionary that has key, value, key, value, key, value, and then they can be in any order and it will insert them in the correct spot. So even if sensor ID was last in my dictionary, it would get it inserted first here in this list. It still means when I construct this SQL statement, I needed to know what order the fields were created in table sensor. And once again, I'm not confident I'm going to know that. Possibly I could be, but it's I find it easier just to say, okay, let's just assume I don't know. Is there another way of doing it? And that's this. You say insert into table sensor. This is the order I want the fields to go in to table sensor, and this is the order I want to grab the values. So I'm being very specific. It's pulling them out of a dictionary and putting them into the right spot. So my sensor ID is getting put into ID sensor, into the location. Similar location ID goes into ID location. Location name goes into text location. Sensor type goes into text type. Unit of measure goes into text unit. And I can see even just by looking at that statement that it's correct. Okay, so I'll run that cell. It's stored SQL, so I'm getting stuck with the last one, which is what I want. And now I'm going to connect. I want the results to come back as a dictionary, and I'm going to execute that SQL. And you see now I provide a comma, and this is the data that I'm going to supply to it. So remember, I've already got the data. I've got some data. Here's some data. So that data there is going to be bound to that SQL statement up on the server, and then I'm going to run another command to query all the data that I've put up there and get it back, and it should be one row. So let's run that, see how we go. And the data's come back. Yay! ID sensor, E1515, location, and that's all come straight from the database, having put it in. All right, now let's just talk a bit about transactions. And you've probably seen that I've been using this with command. With is a very good thing to use in Python code. If there's ever a place that you can use with, then use it, because it'll clean up after you when you leave that code block. So it's commonly used when you're opening files and writing to files. You do that all inside a with context, they call it. And once you leave that context, so after the with, you're indented 4 spaces, you do all the code inside that context, and then when you go back to outside the context, because you're no longer indented, Python will automatically clean up after you. So for files, it'll close up all your resources. Same thing with network sockets and things like that. But here, we're doing a database connection. It'll clean it up. It'll automatically close the connection. Otherwise, it could be left open if you don't use the with statement. But in PsychoPG, it actually does a bit more than that, and it's because of transactions. So transactions were a thing originally came about from banks, because they wanted to make sure if they took money out of one account, and say there was a program that took money out of one account and was supposed to put money into someone else's account from what had just been taken out, but the program crashed in between the two statements, then suddenly no one knows where the money is. It's one person's lost it, the other person hasn't got it. So they created a thing called a transaction, that if they're either both committed or neither are committed. So you do all the parts of the transaction, and then you say commit at the end, and then they all get committed at the same time. All right, so if you use a with like this, then that is roughly equivalent to saying I want to create a connection, then I'm going to do all the things that I want to do with that connection, which is changing data, pulling money out of one account, putting it into another account. If there's something that happened along the way, some sort of exception, then I'm going to roll it back. So none of those things will have happened. However, if I get to the end and I haven't had any exceptions happening, then I'm going to commit those changes. So this is the long form of the try statement that you possibly don't use yourself, but this is what it's being used for. And then once I've committed those changes, I know that you're no longer needed this connection, so I'm going to close it and free up those resources. So it's there's quite a lot of good programming practice here that's all tied up in using the with, and Python just takes care of it for you. So I recommend always use with if you can, because it just makes your code so much more robust. Okay, challenge 3, insert the second row into the table and display the full contents of the table. Okay, so there's not really anything special here. There we did one row, just list meta index 0. Here we'll do the next one, list meta 1. And when we do a select star from table sensor, we get all the records coming back. So that's good. So how about doing the rest? Now we could just do a loop and run all these cursor.execute through list meta 2, 3, 4, 5, 6. Or there is a command in Postgresql psychopg called execute many. You give it the SQL that you want to run, and then you give it a list. So we're starting from 2 and going right to the end of the list of records, and it'll just keep running the SQL for all of those. There's no speed benefits in doing this. It's like in SQLite, there's an execute many command that does give you speed benefits. In Postgresql, there's no speed benefits from this way of doing the command. It's really just a typing benefit for you. But let's run it. It's still pretty fast. Like we just did 92 records then pretty quickly. And you can see this is the command to find out how many records are now in the table. Select count. So we've just done 90 because there were 2 there already. And it's that's the SQL to give it back, and the row came back as 92. All right, try inserting the first row again. So I've commented this out, but if you're following along, then try to uncomment it. And I'm also, like we could have done it with the connect, and then inside the connect create a cursor. In fact, I forgot to mention up here, you'll notice that I had nested with statements on having the cursor in one with statement and the connect on another. You can actually with statements, this is just a feature of with statements, nothing to do with psychopg really, is you can nest them all on one line. So we can say this is our first with statement, then a comma, and then we've got our next with statement with con.cursor as CUR. So it saves a bit of typing if you want. And then here I'm putting even more into the with statement. I'm from the connection, I'm creating a cursor using con.execute. If you do con.execute, it'll go, well, you must need a cursor to execute something. You haven't created one yet, but it will stick that in the with statement, and it creates it. So it's just another way of doing it. Do what reads best for you. Don't worry about thinking which one's the most economical, but whichever one you can read the best, that's the one to use. Okay, and we're going to insert one row of data, which we actually already inserted before. So let's see what happens. Okay, now we get a violation, a unique violation, and that's because we created a primary key in our database on sensor ID, and the primary key is a way of other tables in your database referring to a particular record in this table. So you can't have duplicates in the primary key, otherwise it doesn't know which record you are referring to. So by saying it's a primary key, we've now got a problem that we can't have, well, maybe it's a good thing, we can't have duplicate records with the same primary key. So PostgreSQL automatically handles that for us and makes sure that that's not that problem doesn't exist. It tells us here E1515 already exists. Okay, so that's our metadata. Now let's have a look at our measurement data. And you can see here we've got a measurement date, and it's got a date, a time, and a time zone, all stored in a string, which is how you use JSON. JSON doesn't have a date format, so you just store it in strings, and that's a pretty common way of storing dates and times in strings for JSON. And then it's got a sensor and a reading, another sensor and another reading, another sensor and another reading. And for people who've used Pandas, this seems like a pretty common thing to do. When you get more data, another sensor, you just add another column onto the end of your data frame. So data frames handle adding columns really easily. Databases do not. Databases, every column is part of your data structure. You don't want to be having sensor names in as part of your data structure, because you've got to create tables and alter tables with sensor names, and someone goes and changes the name of the sensor. You know, what are you going to do? Change your whole data structure in the database. So databases are great for adding rows. So what we would do in this situation is do what's called melting the data. Like if it was in Pandas, we'd run the melt command to change this so that each sensor got its own row in the database, and the database basically just said, what's your sensor ID, what's the value, sensor ID value, sensor ID value, and all of them would have a time of measurement. So here's a data structure that we're going to use for the database. And we're going to, I won't bother using pandas because that's just an extra complication, but we'll flatten the, we'll unpivot the data just manually in Python. All right, so we're going to create this table. We're not saying what the primary key is, that's okay, but we are saying what the foreign key is. We're going to use ID sensor as a foreign key on this sensor metadata table, and that's how we specify that. So let's run that. All by running it, we just created a string for our SQL, and now we will run that SQL and create the table in our database. And now let's prepare our data so that we can insert it into the database. Now, our JSON strings for time are not great. You could, like, they'll sort chronologically, which is not bad, but you can't do any arithmetic. You know, tell me what the date is 3 days after this one. So what we'll do is we'll convert them all to proper dates and times that you can do data arithmetic on. And we do that just using the date time library string paths time. So it's going to take in a string and a format, and that's our format for that that one that they're using, which is just year, month, day, hour, minute, second, time zone. And let's just create a new field at the end of each of these dictionaries called date time measure. There we go. So we've done that for every single row, but let's just have a look at the first one, and we'll look right at the end, make sure we got the right thing. So date time measure is a datetime.datetime, year, month, day, hour, minute, there were no seconds, and time zone is UTC, which is correct. there is their UTC time zone, no seconds, hours, minutes. Okay, so now we've got that data, we can create our insert commands and put that into the database. So we're going to loop through our dictionary and save it here. So once again, we've got our SQL, which is got both our table fields and our binding, named bindings. And for each time we run through it, we're going to pass the data as a dictionary into that SQL, and that will get inserted. So let's run that. And then we've just checked the data coming out at the end, limiting it to 5 records, and we can see we're getting date measure, which is the same of course for all the first few ones, and our ID sensor and what the measurement was. Okay, so what have we done? We've done one row out of our list of data. So let's do the rest. So we just loop through from record 1 onwards, because we've already done record 0 in our list. And we've now got 5,535 records. So that happened pretty quickly. This database stuff is quite fast. That's why you use databases, because there's very fast ways of using large amounts of data, and we're not even really touching the surface of what they can do. Now if you want to get data out, you're better off to use the database itself for running the queries, because rather than pull everything into RAM and doing Python comparisons, the database can do that much faster. So here we want everything in degrees latitude, which is greater than 27.4 degrees south, and it's got an ID sensor that starts with E18. So it's just a typical query, and it comes back with 6 records. So that was a query on the metadata table. You can also query relational data. So remember we've got 2 tables in there now, and one's got a foreign key linked to the other. So the measurement data is linked to the sensor data, and so you can use this join command here to join them. There's a select, so we have to select which fields we want. We have to specify which tables. Now we could say select table measure.date measure, table measure.rl measurement, but you'll often see people in SQL statements, they'll create these aliases. So I said from table measure, which I've given an alias M, joined on table sensor with an alias S on s.id sensor equals m.id sensor, and see I've just used those aliases all the way through. Okay. So I've connected to the database and got the data out, and I printed out this nice table using F strings for getting all the columns to line up nicely. So let's just check that we've got the right sort of data. Let's have a look at our record for E1843, which is everything that's printed out here. You can see this is the original data. It had gap, 0.27, gap, 0.37. And here is, we're not showing the gaps. We decided that they're not measurements, so we're not even going to record them. And then our first one is 0.27 at 11:55. Then there was a gap, and then the next one is 0.37 at 12:20, and then a gap, and then 0.47, then 0.62, 0.72. You can see here they're quite close together in time, and then when there's gaps later, it's a bigger gap. So it looks like it's working okay. I'm not sure what interval they're using here. It's obviously not constant. Okay. Now you saw before we had data constraints on using the primary key. You can actually create that sort of constraint on anything. So for example, a useful one in our measurements was to say that each sensor at each time should have only one measurement. So let's create a unique index on the measurement table we'll call it index sensor time, and it's a unique one, which means that we can't have two records with the same value of date measure and ID sensor. So easy to create. Now if I uncomment this bad line here and run it, you'll see I'll trigger that unique constraint because I tried to add in something that previously existed. And you see here where I'm adding in the data. I did this up above, I forgot to mention it. I've had to convert the K field, which is the sensor ID, to uppercase because that's what it was in our sensor table. Alright, databases are just fantastic at aggregate functions like summing and counting on groups. Like I'm just astounded. You get like 2 orders of magnitude faster running it in the database than trying to run it in your Python code. We'll run this one here, so we just want to check all the records, find out which is the most frequent. What are we checking? Where anything that's got more than 3 measurements, and we want to find the total of the measurements in the table. That's a reasonably tricky thing to do, but databases just do it at the drop of a hat. So you just create a field called count or called frequency based on the count of records. Asterisk just means the whole record, and calculate the sum, and we give it a new name, total, and you use the where command in SQL for when it's a particular field has some sort of condition, like you don't want it to be 0, but you use having when you're checking out a condition on some sort of aggregate function, like having a sum that's greater than a certain value, or having a count that's in this case greater than 3. Okay, and there's our data. Now we can update it, so we want the sensors to have use lowercase rainfall rather than uppercase, and that updated 48 rows, and now if I do a search on anything with an uppercase R in it, I get nothing back. Deleting data, we can delete everything which is of type rainfall, so it's just going to leave the stream height data, and that just quickly deleted 4,800 records, leaving 735. Okay, now in PostgreSQL you've got different data types, int 2, int 4, int 8, and in Python they all just equate to an int, and that works like if you've got a 2-byte integer, so 2 bytes only gets you up to 255, but Python can PsychoPG can tell if your integer is bigger or smaller than 255, whether it'll store it in your integer, and it'll store it up to 8 bytes. We've also got these ones, serial 2, serial 4, serial 8 in PostgreSQL. Yes, I left out the queue. And that is an auto incrementing, so if you wanted to have an ID on something that, counting up 1, 2, 3 every time you added a record, it automatically counted up the next number, so it's a useful way of creating IDs. You can use serial 8, and once again Python can, it's got to stop double clicking, Python can store that in an integer. Now the problem comes when you come to floats. Floats can only relate to float 8 and double precision, which are both the same thing. You can't go from a Python float to a PostgreSQL float 4 or real, because Python floats have a lot of precision whether you're using them or not, and PsychoPG can't tell how much of it you're actually using. There's numeric data types, booleans, trues and false, varchar, which is for variable levels of text, dates and timestamps. Now what I found interesting is these ones, JSON, JSONB, and arrays. So I've been using a bit of MongoDB just because I wanted to store some JSON stuff, but now PostgreSQL can do JSON as well, and XML. So let's have a bit of an experiment with that. We'll create a table that's got a JSON field and a JSON-B just to see what the difference is, and also some array fields, and that's how you specify them. This is the SQL to create the demo. We'll just run that, and we will have our dictionary, and we'll store that into our SQL. Now when you've got a dictionary, you have to convert it to JSON or JSON-B. So let's try both of those. So remember, in the database we've got one JSON and one JSON-B, and in the SQL for inserting it, we're going to do both of them as JSON first and both of them as JSON-B second. And then we get the data back out, and we'll see that the JSON-B demo, the stuff comes back in a different order. So what's happened here is the JSON-B has converted it to a binary. So the B stands for binary, and it's just optimized it in whatever way it needs, and so it's ended up sorting it out in alphabetical order of its keys. But by doing that, you can index it and search on stuff inside it more easily. The JSON, straight JSON, it's a string, so it goes, well, you really want to preserve this exactly as it went in, so it'll bring it out exactly the same way, and that's just what it is. So we can see that JSON does the parsing when it reads it back, like it is actually a dictionary when it's come back, but JSON-B parses it into a dictionary when it's saving it and into the database. Alright. Now the problem is JSON can't serialize datetime objects. So for example, if I create a datetime object inside my dictionary and then I try inserting that, and I'll get nothing there because I haven't enabled this. There we go. I'll get a JSON error. It's not really a PostgreSQL error because PostgreSQL can handle dates and times, but you would just use, in that case, you would use a field that was of type date time. Finally, is a demo for arrays, just to show that you can store an array of numbers. I've never needed to do this, but I'm fascinated that it's now an option in databases, and so there's some examples of what that looks like. Alright, so were there any questions? Nothing's come through so far. That's the end of my session so far. Arun will be taking the next couple of weeks. Then I'll do an absolute beginner's session on functions at the beginning of July, just ahead of our meetup in-person group at Amazon Web Services. So if you do RSVP for our Amazon, remember to click on the link to go to our extra registration page, so that you can you just have to have a Google account, sign in with your Google account, and that'll store your email address. But if you could then edit your record to say what your name is in Meetup, because we just need some way of linking the two. Meetup only gives us your nicknames that you've used. So yeah, if you could provide us with your nickname by saying the update member details. And if you have any problems using that app, just let us know on Slack and we'll get through to you. Thanks, Scott. I seem to enjoy the session, so that's great. I hope you find it useful. The one we did at the precinct in Fortitude Valley, a lot of people took. I was surprised how much interest people took in it, and I guess it's because we get a lot of data scientists coming into this group, and they just love data. So to them, a database is just heaven. Okay. Until next time.